Welcome everyone. My name is Jay Shah. I'm the product marketing director for GE Vernova Grid Software's distribution portfolio and for Grid OS grid orchestration software. I will be one of the presenters and the moderator for this webinar. Let me now introduce you to our other presenter. Paula Restrepo leads product management for GE Vernova's distribution and ADMS portfolio. After the webinar, we'll have a Q&A session. So please type out your questions in the chat window and we'll try to answer them during the Q&A. You can also book a meeting with us to learn more, take a survey, or leverage our chatbot for a live chat with our sales team. So the grid is facing significant challenges. Severe weather events that cause significant disruptions and outages are going up. Electricity consumption is going up significantly due to electrification of transportation, resulting in even higher peak loads. At the same time, more intermittent renewables are coming online, especially distributed energy resources or DERs that result in generation now happening close to consumption. This is producing multi-directional energy flows as opposed to unidirectional energy flows from generation to transmission to distribution of the past. At the same time, grids are seeing more cybersecurity threats. So what do all these threats mean for the distribution control room? The distribution control room of the future will need to be more proactive versus reactive. It'll need to be more prescriptive and automated with strong situational awareness for operators, along with exception-based control, where decisions will be presented to operators to choose from versus them having to manage all the steps manually. It'll also have automation for specific use cases, especially during events. The control room will need to manage with fewer control room operators due to the talent crunch that utilities are facing, and decentralized control to remote operators and field personnel. It'll also need to provide a whole wide view of network operations across transmission and distribution to manage the multi-directional energy flows and provide visibility to loads and generation, both real time and in look ahead across transmission and distribution. The distribution control room of the future will also need to provide resiliency against increasing weather events. So proactive preparations, strong workflows during storms, and faster restorations will be critical to manage these threats. The control room of the future will also need to orchestrate distributed energy resources or DERs, not just by manually controlling them, but also by optimizing them operationally to avoid grid violations and economically as well to unlock the power of DER flexibility. If distribution operators had to manage the grid in traditional ways by overbuilding the grid to manage to peaks, they would need a massive hardware investment in infrastructure. The control room of the future can help optimize this investment by unlocking non-wire alternatives to balance the grid. Let me now hand it over to Paula to take us through how to address the first four needs.
Thank you, Jay. The first need is to be more proactive, more prescriptive, automated versus reactive. It will be a much more of an exception-based operation where instead of pushing buttons for every operations, operators will be reviewing decisions and exception-based on a proactive analysis, which will save them a lot of time. In addition, it would also have automation for specific use cases, specifically during events or several events. A second element is a situational awareness workflow. There are 4 important user experience elements for every distribution control room for an efficient workflow and to bring relevant data and insights easily to the operator's fingerprints. First is the monitor with dashboards, is the ability for the operator to have everything at its fingertips. It will have the dashboard with all the information it needs and easily go to different locations or different places where he needs to do some work. It will allow him to monitor the system and correct the issues that arise. These dashboards also can be done for the operator, but then can also be accommodated for an analyst, an engineer, or someone in the business level that just wants to see the overview of what's happening to the system. The second important experience element for every distribution control room to have an efficient workflow is to identify exceptions with alarms. All alarms provides the focus and allows the utility to react to unplanned events and correct any issues. In addition to that, there's the need for that situational awareness for evaluation with the network viewer. Having the geographic display and providing the operator with the context and the situational awareness of what's happening on their network and their area of responsibility. Action and correction with workstation. So they will have all of the workflow in one place, in one workstation, where users can evaluate, plan, and correct. Now let's move to exception-based control and automation. Closed control loop could have a couple of options depending upon the dynamics and maturity of the distribution grid. This will present decisions for operator to choose from, or drive full automation by enabling the software to drive the decision and the action. So an open loop solution, let's take Flizzr, fault location, isolation, and restoration as an example. If you have that in open loop, it will present the decisions that the operator can choose from. But if you choose to use Flizzr in closed loop, it's able to have full automation and control, driving meaningful impact on KPIs like safety and SAIDI. Let's move into the need to manage with fewer control room operators. The decrease in experienced operators is causing a talent crunch at utilities. The exception-based grid operations versus push-button-based operations will need fewer operators. The decentralization of control room operations to field personnel will also reduce control room resources challenges. COVID disruptions have resulted in the need for remote operations. Future pandemics may drive further needs for remote operations as well. So there's two ways for decentralization: operators outside the control room and mobility for the field personnel. For operators outside the control room, you would be able to manage outages and events that quickly overwhelm our centralized control room. During such events, it is important to ramp up the resourcing beyond just control room operators to remote operators as well. This could be some of your engineers, this could be some of your other operators from outside the state, this could be different operators or resources that are not in a day-to-day operations at the control room. That's where having a web-based client UI that can scale control room operations to outside resources with computers and laptops is critical. An outage management system is a perfect candidate for such a functionality so that the right crew can be dispatched at the right location during these events. The scaling of the control room is not just applied to remote operators with laptops and computers. It should also be able to scale up to include field personnel with mobile devices, enabling field crew to collaborate with the control room for switching decisions or for outages to ensure safety, to get visibility of the current network status, and to help during outages are excellent field use cases to implement. Mobile switching and mobile OMS are great starting points for the introduction of mobility to your control room. This will really empower your field control to collaborate across your in-control room operators. Will give them complete visibility of the network, how it's operating in real time. This will reduce your back and forth and communications across the control room and the field crew, and will also avoid delays in communication, errors that can result from miscommunication, and safety incidents with the field. So As I stated before, mobile switching and mobile OMS are really a great starting point for introduction of mobility in your control room. Now let's move to integrated T&D coordination. The modern distribution control room will provide a whole wide view of network operations. For North America, as the grid moves from an unidirectional energy flow to a multi-directional energy flow, the control room of the future will be integrated across T&D, transmission and distribution, allowing better coordination across TSOs and DSOs for forecasting, switching, fault restoration, simulations, and emergency response. Let's take a couple of examples that emphasize the importance of forecasting across T&D. The first case is about DERs impacting transmission. In Australia, on March 16, 2021, there was a sudden cloud cover that led to a 300 megawatt drop in rooftop solar in the distribution side. This led to a frequency drop on the transmission side, as a 300 megawatt drop was equivalent to a large generator tripping. Hence, the need for transmission to have visibility in distribution to plan for something like this in advance. The second case is about bulk renewables impacting distribution. On June 27th in Netherlands, there was a strong wind and sun, leading to bulk wind and PV generation peaking, causing an imbalance in transmission and resulting in the TSO asking to DSO to curtail DERs. Hence the need for distribution to have visibility in transmission to make these decisions in advance. So again, it's being more proactive versus reactive in the control room. DER generation tends to hide or mask native loads or consumption, resulting in net loads that are lower than native loads. Imagine a situation when there is a sudden cloud cover or when a PV smart inverter trips due to a fault. It will result in a load that's much higher, as the DER generation that used to hide or mask the load has reduced to zero or gone down significantly. This results in a significant impact to the grid. Hence, from the perspective of predicting loads, forecasting need to estimate net loads, hidden loads, and native loads to ensure that the sudden increase in loads due to reduced DER generations does not impact the grid. So now let's take a look at forecasting. For transmission operators, they need to have a look ahead and real-time visibility to the loads on the distribution side. Not just look at net loads, the true loads and hidden loads. Weather conditions can change the net loads as the DER generation that makes true load changes. During outages, faults, and events, restoration plans need to account for the true loads and not just the net loads. For distribution operators, getting visibility to bulk generation, especially for renewables, is critical, as these can be intermittent. This allows distribution operators to plan well in advance with regards to load management or buying energy on markets in advance. Now let's move to switching. Having a T&D switching application will really help the safety at the sub-transmission level, which will help the safety at the sub-transmission level. Imagine a world also where you are facing resources challenges and you are able to get transmission operators to focus in the distribution operation room and vice versa. This really lays the foundation for the future control room across the T&D. Let's move to the next need, which is to be resilient. The modern control room will need to protect against threats of the future like severe weather events. It will have proactive and reactive protection against weather events and provide speedier restoration from outages. Here, we will start with outage management and then look at end-to-end disruption management. An outage management system is a must-have for the modern control room as weather events and fires become more frequent and intense. Workflow-oriented system to ensure efficient, rapid restoration, even during severe weather, accurate and rapid data analysis to correctly identify outages, efficient workflow to organize restoration efforts through crew dispatch, roles, and responsibilities, dependable reporting of reliability statistics for use by the utility and the regulatory authority. Really, an outage management system ensures efficient, rapid restoration, correctly identified outages, it organizes restoration efforts through crew management, and reports the reliability statistics. Once an outage management is in place, especially for more mature distribution grids, utilities should consider an end-to-end disruption management, a solution that can help address disruptions proactively and reactively. So at a glance, you'll see a typical high-level workflow for disruption management. The first step is forecast and preparedness and involves better planning for outages by applying predictive analytics and granular forecasts that help identify the risks or the highest risk areas related to the assets on your network. This will help better planning of your outages and in really being proactive in your risk assessment. And then an outage assessment, which will provide the visualization of the network data, reporting on the damage itself and how many outages, and then leveraging visual intelligence as much as possible to help estimate time to restore and number of outages. Next is responding to the outage. Now that the scope of the damage is known, dispatching and working with mutual assistant crews, and then dispatching contract crews where needed to help fill any of the gaps. So how do I restore that network once I understand the damage as quickly as possible while decreasing ETRs and exceeding customer expectations? And then last, the recovery. Once we've got all the outages restored, how do we go back to normal operations or to the normal state of the network, and how do we return to making the process as it was before the disruption or before the outage? How to make this process as seamless as possible and efficient as possible. Now let me hand it over to Jay to talk about distributed energy resources and grid economics.
Thank you, Paula. So the grid of today and the future is very different. The load and consumption profile is very different, characterized by much less predictability due to DER integration on the distribution side, and much higher peak loads due to EV charging, resulting in violations, mass loads, DER curtailment, backfeeds, and other disruptions. The distribution control room of the future needs DER functionality integrated into ADMS to avoid having two different control rooms and to ensure that the impact of DERs on the grid is proactively addressed. For utilities taking their first steps into DER management, DER control is a great starting point for the control room. Most DERs are connected and controlled over the internet. Communicating securely with DERs over the internet with standards-based communication protocols is very important. Control rooms not just need to be able to communicate to DERs directly, but also to groups of them or through aggregators. Dispatching and curtailing DERs and tracking their performance is also a critical use case. Consider the certified, secure, scalable, and highly available IEEE 2030.5 protocol to communicate with the DERs on your grid. For utilities that have mature situational awareness of DERs, they can use forecasting data and grid OT data to drive look-ahead analysis so that they can anticipate what will happen to the grid. For example, if it's going to be a very sunny day in the near future, a grid with high DER penetration may have the potential for backfeed violations or abnormally high voltage levels due to an excess of supply. The look-ahead analysis allows grid operators to identify such potential future violations and drive future optimization decisions based on not just operational considerations, but also on DER program considerations to ensure feasibility of such decisions, as well as to minimize the total cost of operation. Based on this techno-economic optimizations, utilities can send out DER dispatch signals in advance, preventing potential future violations and taking full advantage of the flexibility inherent in the DERs. Let's now look at the economics side of things. Unpredictable loads, much higher peaks, and intermittent distributed generation makes balancing the grid very challenging. Using the traditional practices of overbuilding the grid to manage to peaks will cost hundreds of millions of dollars. For example, a model utility with 2 to 3 million customers would need to invest thousands of dollars in grid upgrades per electric vehicle through 2030, according to the Boston Consulting Group. Assuming tens of millions of EVs on the road in the United States, that investment could reach hundreds of billions of dollars. And accessing the spot markets to address higher and more frequent peaks and balancing the grid is also very expensive. Hence, there is a need to maximize the use of the existing infrastructure by deploying non-wires alternatives. However, for any non-wires alternatives to succeed, distribution utilities and control rooms need real-time and look-ahead visibility into grid behavior. There is a need to go beyond real-time visibility by getting a look-ahead view of how the grid will behave from a perspective of load and distributed generation in the short term, medium term, and the long term. All three views are critical as weather is becoming very unpredictable and it impacts grid behavior significantly, both from a generation and a load perspective. Thus, visibility and forecasting are a critical requirement and the foundation for any non-wires alternatives use cases. Non-wires alternatives can involve three use cases to maximize existing grid infrastructure. The first one and the easiest one to implement is demand response programs to help manage and shift loads away from peaks by incentivizing customers. These can have a wide spectrum of automation, from sending emails to customers to automatically controlling non-mission critical but heavy loads in customer homes. The second one is for grids with high EV penetration. Similar to demand response programs, managed EV charging programs entail managing and shifting EV loads away from peaks. These also can have a wide spectrum of automation, from sending emails to customers to automatically controlling EV charging points. For grids with high DER maturity and situational awareness, using DER flexibility provides a great lever to balance the grid. PVs and batteries can be dispatched or curtailed depending upon what the grid requires to balance in real time and in look ahead. However, it is critical that DER owners are compensated accurately for the use of their DER flexibility. Such non-wires alternatives can help avoid costly investments in infrastructure to balance the grid. Now, let us look at what are some of the prerequisites and foundational elements to achieve the distribution grid of the future and the distribution control room of the future. The biggest foundational element to achieve the modern distribution control room is a clean and accurate network model. Bad, missing, or incomplete data, like broken topology or unknown wire arrangements or network phasing, can result in a bad power flow and DMS not working accurately, and almost all applications like Flizzr running wrong. Without an accurate network model, OMS may not work accurately as well, resulting in inaccurate dispatches to wrong parts of the network, delays in restorations, and incorrect KPIs to regulators. Thus, a clean and accurate network model is one of the biggest needs for a modern distribution control room. Utilities will also need to deploy analytics, artificial intelligence, and machine learning in their applications to enable powerful use cases. Prediction use cases such as forecasting loads and generations and outages in advance before weather events hit will need to use these modern technologies. Similarly, closed loop control use cases like fault location isolation and service restoration or FLISR and DER techno-economic optimization will need to implement these technologies to enable automation. Unlocking a grid digital twin to drive scenario analysis, simulations, and a self-describing and a self-healing grid will also need analytics, AI, and ML. Utilities will also need to deploy and scale applications where they are needed, whether on-prem, in the cloud, or close to the edge. Depending upon the use case, whether it needs to be closer to the grid asset or whether saving costs with cloud deployments is essential. Having a flexible cloud-enabled solution is going to be critical for deployment on-prem, in cloud, hybrid, or close to the edge. To get all these advanced grid management functionalities, utilities need to drive faster grid modernization by deploying advanced applications quickly. However, new deployments and upgrades can be lengthy and expensive. Utilities hesitate to take latest versions because of costs and change management challenges. Hence, there is a need to significantly reduce time to value and deployment costs to speed up initial deployments and move from upgrades to continuous updates to receive new functionality frequently and quickly. This is where GridOS grid orchestration software comes into the picture. GridOS is the first software portfolio designed for grid orchestration. We are bringing operational data, enterprise data, and network model data, and stacking AI apps on top of it. GridOS is a composable suite of products from GE Vernova, partners, and customers that orchestrate an integrated, flexible, and a secure, sustainable energy grid. There are these few key components that I'd like to talk about. Zero trust cybersecurity is at the top of the list. If it isn't secure, it's not going to work. Federated grid data fabric, allowing us to pull together all the data that you need to make decisions and applying it all to a single network model. Our suite of applications that are AI ML driven, all on a hybrid cloud architecture, able to be deployed on-prem, on cloud, or on edge when needed. Let's look at GridOS architecture and see how it addresses the prerequisites of the modern distribution control room. The bottom section is the platform, and the top section consists of applications. The first level is zero trust grid security that is built in, not bolted on. This is the first layer that enables the other layers to play in an efficient way. Next, we have grid orchestration engines that provide common services to applications. Then the most important layer that unlocks the distribution control room of the future is the federated grid data fabric and the one network model, a necessary tool to remove data silos and bring together disparate data sources across the enterprise to provide a unified view and enable coordinated decision-making across transmission, distribution, and the edge. Now, this platform enables our set of AI ML-enabled composable and scalable applications. Thus, GridOS easily fulfills the prerequisites of the modern distribution control room of the future. Let me now hand it over to Paula to talk about GE Vernova ADMS solutions and summarize before we start our Q&A.
Thank you so much, Jay, for the introduction again. So for GE Vernova, we have a distribution optimization for optimizing your network end-to-end, an outage response portfolio for that end-to-end orchestration and outage response and management, a renewables and DR orchestration, where your ADMS is not only aware, but is able to orchestrate and work with all the renewables that are in the network. We also have additive solutions to connect, integrate, and operate. We have a GIS network, a cybersecurity, a T&D model management, and bringing more use cases for the operators of the future in the control room with common T&D applications. We have analytics and mobility. We have the end-to-end portfolio that will help and enable your utility to bring the best value in operations room. Last but not least, I want to talk about our GridOS Evergreen testing and deployment. We have a rapid delivery transformation suite that is composed of GE hosted in managed cloud environment that includes a continuous integration and deployment for faster time to value due to earlier integration testing, delivery, and deployment phases. Other utilities or industries will refer to this as the blue-green environment. That allows for continuous cloud integration and deployment, or latest release, automated testing, and faster feedback, all virtually. Overall, if you update more frequently, you get to lower increments and are in the way to go from upgrade to update. Other benefits is faster feedback. You'll be able to provide product feedback earlier in the delivery cycle and identify bugs earlier through automated and manual testing. You'll have a virtual system with no hardware procurement, no maintenance, and very minimal IT support. And this will also increase quality. It will help our customers reduce defects by addressing customer tests earlier in the cycle in an automated fashion. GridOS really, with this evergreen and testing and deployment, really enables the fastest time to value for new installs and while evolving from upgrades to updates in our existing utility base. With that, I will open the floor for questions.